Hello everyone and welcome to the R programming workshop given by Ebude Yolande, and you can call her only Yolande. I am Wedad Anbtawi, the organizer of this workshop on behalf of FruitPunch AI and YATS. Hope you will enjoy this workshop. So now Yolande will start.
Workshop. To start, I'll just say this is a workshop for data science and AI beginners, and it's going to be 1 hour, 30-minute session. And Wedad already sent you the documents to install the documents, and she sent you RStudio to install. But if you haven't done that, you have a link in the tutorial sheet to download RStudio and install. Also, if you already installed RStudio, you can always update your version with the coding in the tutorial sheet. I hope everyone has received the tutorial sheet. If you haven't received, just signal in the chat and Wedad is going to send you the tutorial sheet. What I want us to do is that as you see me go through the tutorial sheet, it will be good for you to also do it at the same time because it's a workshop. So you follow what I'm doing and you execute it yourself. So if you have any question, just feel free to ask, let me know. Today we have 2 data sets we're going to use. We have one which is an IoT sensor data set, and the other one it's a bike share data set. You'll find a link on the tutorial sheet to download. Do I have to give, so I'll give you 1 minute to go and download the data set and put it in the folder where we can use. Has everyone downloaded the data set? Okay. I don't see the chat, so I cannot see if people say yes or no.
We have one yes.
One yes.
So you can assume like they downloaded the dataset,
Okay.
Otherwise they will.
All right, so I assume you all have downloaded it. Okay, so today we are going to look at how a data scientist or AI beginner can use R programming. The reason why we teach R programming is because R programming is used in many companies today. You have Google, Facebook, IBM, Accenture using R programming, and R programming is very good for statistical analysis and even data visualization. And it's really a good software for research. So therefore, as a beginner in data science and AI, how do we, what do we need at the beginning? So the first thing is, how do I import data sets into R? How do I check the columns, see what I have? How can I get brief information about my data set? How do I pull out a portion of the data set that is useful if I have big data? And how do I merge many data sets into one when I'm in RStudio? Next thing is, how do I visualize this information in my data set? And lastly, because we code a lot, how can I reuse my code in the form of functions? And how can I import a script into an R notebook or script I'm currently using? So this is briefly what we'll be doing when we go through this worksheet. So I'm going to switch. So I'll stop sharing and switch to RStudio. So if you open RStudio for the first time, you would see the framework like this. So up here, you're going to see the different files. This is a notebook. This is a script. And on the bottom right, you can find the console. And in the console, you can do any mathematical formula operation. like, and you would find, so you can assign even variables and you get result in the console. But on the left-hand side, you will find file, plots, packages. The packages is the part I really like because you can instantly install packages into RStudio. So if I'm looking for a package like JSON Live, it can come here. I see the package and I can install, and it will install immediately. So which is really good. And you have the help. The help is where you would find information about the package or about the function, and it will be given out detailedly documented. Now up on the left-hand side, you'll find variables that are created during your work session will be available there. So you have variables, values. You also have functions. If you create functions during your work session, you will find these functions there. Now, how do I get a new script? If I need a script from here, I need to go to File, New File, and then I can choose if I want an R script or I want a notebook. Okay, so that's just the basis of how RStudio looks like and what's important to look out for. Now we are going to dive into the working session. What I advise you do is open your RStudio at the side of your computer and follow what I do. If you have any question, don't fail to write it out, and I would answer this question. To start, we're going to start immediately with dealing with columns in the data set. Now, the first thing is to import the data set into RStudio, and that's what we're going to do immediately. So we have the CSV data set from which is the IoT telemetry data, which is a CSV data set. In order to import it into R, you use the command read.csv. Read.csv is a function already in R, so we do not need to call a package to use this function. And in order to assign it to a variable, we use this symbol less than and hyphen. Less than hyphen is an assign symbol used in R. You could also replace it with equal to if you want, and it does exactly the same thing. Now, in order to view this data set, we are going to use the function view. The function view is going to open up to another page where you'll see all the data set from the beginning to the end. You can scroll down and you'll see everything available here. But what we're going to use throughout this workshop is head. Head takes the data frame and the number of the number of rows you want to see. So head data frame 3 would produce 3 rows. And there you go. So you find this is the data set. So now it's a data frame in R. So it has the column TS, device, and those are the various columns. Now, if we want to get information from these different columns, just to show you, when you look at the header, you see DBL, CHR. DBL stands for double, so it shows you that all the values in TS are doubles. If you look at CHR, that's character. So all the values in device on the device column are characters, and so you know exactly what each value, the type of for the value. Now, if you want to see like brief information of maybe the mean, median, the max, you can use summary. So when you check summary, you find the values like mean, median, max, and yeah. But then if you want to know like a little bit of information, like how many rows do I have in these data frames? So you can use number of rows, that's n row. and it gives you the number. If you want to know how many columns you have, you can use ncol, and you get the number of columns. Another way of doing that is just simply using the function dim. Dim will produce a list of the first element is the number of rows, and the second element is the number of columns. Now, looking at the header, of the data set, you can find at the header, you see that you know a little bit about the type of each of the values in each column. But then what if we want to know the class for each of the columns? So we are going to use a function called sapply. So sapply takes the data frame, and then it uses the function class. And when you do that, it describes each of the columns in the data set, what class they represent. So in the column TS is a numerical column, and the device has a class of, it's a character.
Yolande, for read CSV,
Yes.
only we have parameter of a file name, or we have another parameters? Because I know Python, we have different parameters depending on the CSV file.
Oh, in read CSV, you have other parameters. So when you start writing read.csv, you would see the parameters show. Can you see that? Now,
Yes.
then in read CSV, the important parameter is just the file. The other ones are even if you don't put them, they don't matter. Like header, you can decide to, if you put false, then it wouldn't show you the header. You would have just a data set that starts from 1 to without the header. But what's important is just the file in read CSV. That's it. Okay. All right. So that's a good question, because if you know a function, and you don't know how to use it, you can use the help. So for example, we can put help read.csv. We want to know what this function does and how we can use this function. When you come to the left side of your R Studio, you would see a documentation of this function. And one good thing is that R also documents at the same time other functions that are in the same group with this function, like read table, read CSV2, and it shows you all the arguments for this function. If you scroll right down, you will see an example. You see different examples of how to use this function. So if you know a function, but you don't know how to use it, you can always use help to help and put the function in, and you'll see the documentation. Okay, so let's continue. So if you look at the data set, when we go back to look at this data set, you see TS. TS is the column that denotes the timestamp, when this information for each device was collected. But if I ask you what time was this device information collected, you cannot give me an answer, because you can see the number is just a number of 1594, and it doesn't really say anything. So in order to change these numbers into an interpretable time, we are going to use the function POXIT-CT. So POXIT-CT is a function that converts numbers like this into a readable timestamp, and it takes in value or a vector of values and then the origin. So in order to, in R, if you want to, if you have a data frame and you want to select a column for a data frame, what you do is you take the data frame and you put the $, and then you see the different colors, columns appear, and you can select. So I select the TS column, and the origin is always set at 1970. Now, now we assign it back to the column just to get just to replace it in the column. And here you go.
And Yolande, another question for the
Yes.
file, you need to specify the path, right?
Okay, that's a good question. You would have to specify the path if you don't put the file in the same, if you don't put the data set in the same folder as the script. So you need to put the script in the same folder with the data set, and then you don't have to specify the path. But if you don't put them in the same folder, then you have to specify the path for the data set. Thank you. All right, so let's continue. So we see right now you can look at the TS, the timestamp, and you can read it clearly. So you know that the information for this device was collected on the 12th of June, of July, on the 12th of July at 2 a.m. So we can tell exactly what time each of the information was collected. Now, the next thing I will target here is the decimal points. When you look at CO, the column CO, you see the decimal points are really too many. And you can see also the LPG and smoke, the decimal points are so many. So yeah, I want to take off these decimal points. I want to have a neat columns. So
Yolande, sorry, I'm interrupting you.
yeah,
I have a question. So we send document which is doc.r and
yes.
solution and that document PDF. So
Yes.
which script is it?
No, in order to follow, you're just supposed to open a new script. So you open a new script, and then you can copy the information from the tutorial sheet. You just copy and you paste in the script. For example, I can show, so I can take this, copy, and paste here and run.
And if they want to know the location of the script, how can they?
Oh, when you open it, you can choose to save the script. So you can decide save, and you can save the script to a location that you desire. So a location in your computer where you can also put the data set to that same location. Is it okay?
I think so. Ursula, is it okay?
Okay. So you can run from, so everything I'm doing, you can do the same thing in the new script like this, just copy from the tutorial sheet, and then you can run each time. Okay. Can I continue? All right.
Yes.
Okay, so where was I? All right, so I was talking about the data points and saying that when you look at the column CO and the column smoke, you can see that the data points are just so many, and I want to reduce them and make the data set look better. So what I can do is use the function round, and I can select the column CO, and then I also choose what number. I can say, okay, I want it to be 4 decimal points, reduce it to 4. And when I run, You can see that column, all the information, and it's rounded it up to 4 decimal point. Now, you can choose to do that for all the columns. You can do them one after another, but then it will take a lot of time. But there is a fast way of doing it where you can do for all your code, all the columns in your data frame at this, just using one command. And this gives me the opportunity to introduce us to a package, a very good package called Pru. Pru is a good package for data wrangling. So in anything that has to do with modifying a data frame, from modifying to append, it has all these nice functions. But first, I would talk about this function called modify. So the function modify if. So the function modify if takes a vector or a data frame, and then a logic statement, and then a function to apply the log on the logic statement. So for example, you have the IoT data frame, and then you have the is numeric. I already showed you that showed you the different columns that have the class numeric. So when I say is numeric, it will check the values in these data, in these columns, and if they are numeric, true; if they are not numeric, false. And this function round will only be applied to those values which are numeric. So those values that were true when is numeric was applied to them. And so when we do that, you can see that it applies to, it does that at the same time for all the different columns. So you can see CO, you can see LPG, you can see smoke. It has been applied to all of them. All right, so that's it about the function modify. But let's look at the package Pru. The package Pru is a very good package. So if we do help Pru, and we run that, you find the information on this package at the left hand of your R Studio, and you can find useful link. If you go down to the second website and you click on it, when you go to this website, if you click on it, you're going to find a cheat sheet. The cheat sheet has all the functions in Pru, and it gives you examples of how to use them, and it's very very clearly written out. Now, another way to check is if I don't want to see, if I'm not looking for how to use these functions, but I just want to know the functions that are in the package Pru, then I use library. Library help equal to Pru. And when I run this, information about the package Pru, you get the description, everything about the library, the license. But when you come after this index, every other thing written here is at the functions, the different functions, and it explains what each function does. And so you can get a list. So you get a list of all the functions used in all the functions in the package Pru. Right now, is there any question? Okay, so I continue with an exercise. So far we have seen how to import CSV. Now we're going to look at how to import a JSON file. Now, the second data set I asked you to download was a JSON file, and we're going to look at how to import that file into RStudio. So the first thing is we're going to use the package JSON Lite. You can install it by going to the package section and you click on install and you can write JSON live. And then you click install and you're going to install, it's going to install this package into your RStudio. Now, exactly, yes, as I said, if you don't know, if you don't have an idea of how this package, the functions in this package, you can always do the same thing I just did up there. Library help equal to JSON live, and you see the information. And here we can find, okay, to convert our objects to and from JSON, you have to use to JSON or from JSON. And so that's how we know the function we have to use. And so that's why you see us using this function from JSON and the name of the JSON file. Now, if you haven't put this data set in the same location with your script, you would have to write the path where this data set is found. Now, when you run this, it's going to give you something that looks like a data frame, and the first thing to do is just to think that, oh yeah, it's the data frame, so I can just work with it as it is. But if you check the type, you realize it's a list. It's not a data frame. It just presented itself like to look like a data frame, but it's a list. And so that's why we have to use as the data frame in order to convert the list into a data frame. And then we assign it to be share. And then you can see how it looks like. Now, in the converting from the list to data frame, it happens that the header was not properly converted. So you find that you have data bytes.bytes ID, you have name, data bytes.name, and this repetition. So therefore makes the header not to look very, very nice to read. So one of the things we can do is modify this header. So to modify this header, first we're going to pull out the list of the information on the header. And to do that, you use the function names bshare. So names bshare is going to pull out the list of the header. You can see all of them written out here. And then we created another list with the modified names we want, and we assign it to names bshare, and it will crush this and assign the new names to it. And that's it. You can see, and it looks better and it's easier to read when you on one view. The next thing is removing informations that we do not require. Yes.
If you can stop a moment here and re-explain like how to download the documents and how to put them on the same folder, because people are like getting lost because not finding the folder.
Okay. The folder. So has everybody downloaded the file?
Yeah, I assume they all downloaded the data sets on downloads file, and I'm not sure where, like exactly, but usually on downloads.
Okay, then they can copy it from download and put it anywhere in their computer, maybe in a folder on the desktop or maybe in a folder on the document.
Yep, I get you. And then for the script.
For the script, yes. For the script, when you click file and you select new file, our script, then you choose to save this file. So save, Control S, And then I have to look for the same folder where I put the data sets. I need to save this file in the same folder. Is it okay? I can continue where we stopped. We stopped at the point where we changed the header and we made it look better off than before. You can see before, and now you can see how it looks better and easy to see the name of the columns. The next thing I'm a little bit worried about is when you look at the ID column, you see bike underscore, bike underscore, bike underscore. It's a lot of repetition of that information. We know that the data set is a bike data set, so therefore every number that is represented in ID is a number allocated to a bike. So we do not need to have bike underscore information in this in the data set. So the thing, what we are going to do is try to pull out this bike underscore and just leave just the numbers, because the numbers are the one representing each bike. Now, in order to do that, we wrote a code that helps achieve this output, the output we need. So in this code, I'm going to take the advantage to introduce you to the syntax of a for loop. So if you look at this code, if I take off this instruction, so I'm going to take it off, you see the syntax of a for loop. So a for loop, you write for, you open a bracket, and you have the iterator, which is denoted here as I, in a range. The range here in R, the range starts from 1 and ends with the last value. So we start 1 column, and then the last value here is just the number of rows, which is dim b shared 1, which is just the first element of the list dim, the list, which is the number of rows. You can as well replace it with n row, and you get the same output. And in order to write your instructions, you need to use a set bracket open and close, and then you write your instructions. So that's the syntax for a for loop. Now I'm going to put back the instructions, and I'm going to talk about the last instruction. So this instruction. Now, append is a function in the pure package. I already showed you the pure package. Append is a function in this package. And what append does is it takes a list and a value, and it puts the value at the end of that list. Now, at the beginning, we created an empty list by using list bracket open and close, and you create an empty list. Now, we're going to look a little bit at this instruction, val. Remember that our objective was to take off bike underscore and have just the numbers. So we want to have just the numbers in this ID. Now, to do that, we are going to make use of a function called split string split. So what string split does is, if I give it a phrase like, let's say, hello everyone, hello everyone, and I tell it to split this phrase in this where you find a space, it's going to do this. So you find hello everyone as two separate entities. And if you want to reference to just make reference to just hello, you can do that by taking the first element. So if I do this, I make reference to just hello. If I want to make reference to everyone, I can put the 2. And now, when you do this we can do the same thing for bike. Now we're going to separate using an underscore. When you do that, you have bike and you have the numbers. Now, what we are interested in, remember, is just the numbers. We don't have any interest in bike, so we're going to take that and take the second element because that's what we're interested in. So you see that. Now, another thing is we don't want a string of the numbers, but we want the numbers. So we want the integer number. We do not want a string of the numbers. So we want numeric. So what we're going to do is to use a function called string to integer. So it's written as tr to I, and it's a base function. When you run that, it converts the string to an integer. So now we have an integer. So now we have just a number, and we can do it for all the values in the column ID. And that's why you see we use the for loop to loop through all the values in the ID column, and then we apply this string split on each of them. We select the number, the second, and then we apply the string to I to convert from string to integer, and then we assign that to var. So each time, at the end of this for loop, we build up a list of all the numbers. So all the numbers in this ID column. Now, we have to assign this list of number into a new column. So we create a new column. To create a new column in the data frame, what you do is you use $, $, and when you're creating a new column, you just write the name of the new column and it creates the new column. But what if you just do that without assigning anything to this new column, it wouldn't be created. So what you have to do is you have to assign a value to this new column. And we take the variable new, which was the list we created. If we assign this variable new to the new ID, it wouldn't work because new is a list and the shared columns are vectors. So therefore, to change from list to a vector, we just have to onList. So onList kind of creates a vector, which can be assigned to new ID. And there you go. That gives you the new IDs, which are just the numbers without the back underscore. Now, after modifying this data set, remember that this data set came as a JSON file. After modifying it, we want to save it into our computer. And so we save it as an Excel sheet. We make use of the library, write Excel, and there's a function called write LXS, and you use bshared, which is the data frame and the name of the Excel sheet you want to save. When you do this, this will be saved in the same folder where you have the script. So this Excel sheet will be saved in the same folder where you have the script. And just above this just above this write Excel, I kind of create a new column. If you look at bshared rect update, it's a new column that is created, and it's created by slicing out a portion from IoT. This is the second part of our workshop, how to select subsets, how to create subsets out of your data frame. And here we're creating out a vector of 21 elements from the column TS. And we assign it to rec update, which is a new column created in the bshared data frame. And when you run that, you will see all the data, all the Excel sheets will be created in your in your folder where you have the work script, the R script. Now, before we go to the second part of this workshop, I would just like to challenge you a little bit with an exercise. So you've seen what I've done. You see, I was able to import the data set, manipulate the data set, do some changes in the data set. Now I would like you to import the BShare Excel sheet that you just created by running this. I'd like you to import that into your script, and I want you to put the last update column. So if you look at the last updated column, it doesn't, you're not able to interpret it. It's a time, but you don't know exactly what time it is. So therefore, I want you to put it into a readable time frame, date time value, so I can read. I think we can do this for 2 minutes. Is it okay? Do you need a hint? Like, has anybody been able to do it? Okay, and the second challenge, you can do it at later on. The solution for these challenges are found in the solution.html file that was sent to you. So if you check that file, you'll see the solutions for all the challenge. So we are going to move on with the second part, which is subsets and merging of data sets. Now, in R, if you want to pick out a portion of rows in a data frame, what you do is you assign, okay, I want to pick out the first 10 rows in the data frame IoT. So I take 1 column 10, and this creates the first 10 rows in the data set. Now, if I want to take from the 5th to the 10th, I've taken the 5th to the 10th. Now, if I want to take just a few columns, I don't want all the columns, I want just a few columns, and I know the columns I want to take, so I want to take device, and I want to also take out CO, and that's it. That's how you do it. And if you don't know the columns, but you know the position these columns occupy, you can take the using the numbers. So I'll take column 3 and column 5, and that's what you get. Final way of doing, if you have like many columns and you just want to pick from the 3rd column till the end, you just pick 3 and you put the column and there you take from the 3rd column till the end. Now, let's continue to a more sophisticated subset. Here we're going to use the function which. Now, we want to pick out all the information about this device, BA27. Now, you can use the function which, and it's put in the position, like it's put in the position of rows. So the function which would collect rows when a logic statement is true. So you have which, the logic statement is IoT device should be equal to the device in which we want, the device we have chosen, and it will collect all the rows for that logic statement. And you can see the result. Now you can also add more than, you can have more than one logic statement. And so you can make use of a logic operator like and, that's how you write and, or you can make use of a logic operator like or. So you write, it's how you write or. So in this case, we use and as well as y selecting a certain number of column of rows. You can also choose to select a number of columns. You can also choose certain columns you want to pick out from. So here we selected the TS column, device, CO, and we assign it to a new data frame. And here you go. So this is the new data frame we've created. Now, another thing is if we know a particular device and we do not want information about that device, so we want information of other devices in that data frame except the device that we already know, we're going to make use of a package, the dplyr, and this package has a function called filter. What filter does is filter takes the data frame and a logic condition to pick out all the rows that coincide with that logic condition. So we put in the data frame, and then the condition here is all of the device except the device that, except the one we already know. And if you do that, you see. Now, just to remind you that to know more about this package dplyr, you can do help dplyr, and you would see the documentation, and you can click on the link and find the cheat sheet available on the documentation. Now, the last thing we have to do before we go into our exercises, when you all have different data sets and you have put them into R as data frame, and now you want to merge them. For example, you see up here, we created 2 new data frames. Well, this is one, and this is the second one. And now we want to merge them into one data frame. So one way to do it is to use rbind, and you merge the 2 data frame, or you can use bind rows and you merge the 2 data frame. So that is it. And now we're going to go into an exercise. If you check on your tutorial sheet, the exercise is written out there. You're asked to create a vector from taking the last 30 elements in the column TS of IoT D2, which is the new data set we just created, and assign it to the first 30 elements of IoT D1, which is the other new data set, data frame we just created. And to do that, to take the last 30 elements, we make use of a function tail. So the function tail would take the last 30 elements in a column that you tell it to do. So we asked you to take the last 30 elements in the column TS of the data set IoT D2. And that's what we've done with tail. And reverse, which is ref is a function that will reverse the order. So instead of having 1, 5, 8, 9, we're going to have the order to be 9, 8, 5, 1. So that's what reverse does. It reverses, it changes the order, and you assign it to the first 30 elements of IoT D1, the column TS. And you can see the modification of that data. So that data set IoT D2, D1 has been modified. Now, we go next to merging the 2 data sets. So we want to merge the 2 data sets at the point TS where all the values of TS are the same. and we make use of a function merge. When you use merge, you put the two data sets, data frames, and you put TS is the column in which you want to do the merge. This merge is different from the rbind. This merge will create the columns side by side. So you can see. So it creates, you asked it to merge at the column TS. So you find TS, and then it creates the other columns side by side. So the names with .x refer to the columns in IoT D1, and the names .y refer to the columns in IoT D2. Now, to end with this section, we are going to look at how do we pull out information in a time zone, so in a time space. For example, if you're asked to pull out the records from the 12th of July to the 15th of July, you can use the function which, and because we're able to convert this TS to a readable timestamp, now you can just put the timestamp and say, use the logic. We want to collect all the information of where the time is, TS is greater than 12 July and less than 16 July.
So Yolande, we have a question. What is the difference?
Yes.
What is the difference between rbind and merge?
What's the difference between rbind and merge? Okay. For rbind does row, joins the row, while merge does column. So merge joins them column. You can see the column lies, the column for IoT D1 lies next to the column of IoT D2. Merge does that. While rbind, if you, let's just look at how rbind. So if we do the header for R, check when we do head, this is how it looks like. So it just merges the rows. So you have everything. The second one is combined to the first one from underneath. Okay. So we are done with this. We are done with this part. You can do the challenge later on, and you have the solution in the solution HTML. You can check, but the first part of the challenge is very simple to do. You just ask to remove the columns, and you've seen how I've shown you how to do that in this workshop. Now we're going to go into another section, which is visualization. Visualization is very important to data scientists because you need to communicate your ideas to people. And so you need to put the information in the data sets. You need to communicate this information to other people in a very beautiful way. And so visualization is one of the ways that you use to communicate this information. Now, R goes from very simple visualizations like HIST, IoT Pro. It will make the it will give you a histogram, to complex plots using packages. So one of the packages we're going to look at today is ggplot2. ggplot2 is widely used in R programming, and it's a really good package. Now, I'm going to take off all of these so that we focus on just the syntax of qplot, which is one of the functions in this. So the syntax of this qplot is you take the x axis, the y axis and the data set you want to plot the columns from. And when you put the data set, so therefore the x-axis is a column from the data set and the data frame, and the y is also a column from the data frame. Now you find this geom, which is, it tells you, tells the function what you want to plot. Do you want a line? Do you want a point? Do you want a bar plot? Do you want do you want a polygon? You can describe it. And now color, in this case, we wanted the color to be demarcated by the device column of the data frame. And you can see the colors are demarcated by the different devices in the device column. Now, main is a way you refer to the title in the plots R. So if you want to write a title, you need to use main, you write this title. Now, that's just the basic syntax. The other things like theme helps you beautify the plot. So if you just run this plot like this, you'll see a different outlook. And if you add the theme and X lab, Y lab, helps you to write the names on the X axis and the Y axis. Now, also, it's important to know how to save images that you plots you create into images. So a very easy way to save plots in R is to use PNG, and then you write the name of the image. You do that, you write that above the plot. When you write that above the plot, it will save this plot in this image.png. So if you run that, you're going to, when you run this, you're going to see the image appear in the same folder that where you run the script, where you have the script. Now, another function that I wanted to introduce is the ggplot. So the ggplot is also part of the gg library. It's a function in the gg library, and it's a little bit different from the qplot. So the syntax is quite different. In the ggplot, the focus is on the x-axis and y-axis, the x-axis and the y-axis. For the ggplot, the focus is the data set first before you write what's going to be on the x-axis and what's going to be on the y-axis. Now, also in the ggplot, you can the geom, which tells you if it's going to be a line plot or a box plot, can also be written out of the function ggplot. So it's an added, it's like an addition to the function. So it's written outside. Now you also have themes that come in the ggplot. So if you write theme, you'll see the there are many other themes that you can select from them and you can use them. Now the Y-lab is the label on the y-axis, and X-lab the label on the x-axis. And a way in which you write the title for ggplot is gtitle. So you don't use main like the other plots in R, but you use ggtitle. Now also, a way of saving ggplot is to use ggsave, and then you put it under the plot. And if it takes the name of the plot, what you want to save, the name you want to save the plot with, and the plot. If you don't make reference, if you don't write the name of this plot, if you take it out, what happens is it's going to save the last plot as the last plot, which will be this. And so if you run that, you're going to find the image saved in the same folder. You're going to find it saved in the same folder with your script. Now, You also have another challenge there. You can do that later on, and you can check the result is in the solution.html. Now, to end this workshop, I'm going to talk a little bit about functions and reusable code. So the reason why I talk about this is because you write a lot of codes. You can write a lot of codes today and you feel good about it and you're like, oh, it's working so well. I'm so happy with it, and it's everything, you understand everything that you do. But then you come maybe 10 days later and you're like, what's this? I cannot understand this, and what am I doing? So one of the ways to do to avoid that is to put comments in your code, and you see me comment using the hash to put comments in the code. That's good, but if you have a lot of things you have written in the script, it becomes a little bit difficult to read through the comments and everything. So one of the ways to avoid, especially if you use a code many times in your script, one of the ways to avoid that is to make functions. So build the function and you can just call that each time you need. So this brings me to how what's the syntax of a function. So the syntax of a function is you write the name of the function, you put you assign the assign symbol, and then function, you put the different arguments. So here we want 3 arguments, A, B, C, and then you have your set brackets open and close. And inside here, you can execute you can write any instruction. So the instructions we had if and else. So the same thing for if, to show you the syntax for if is just if, bracket open, the logic statement, and then set bracket open and close. There you go. So here in the function, when you return, so return, you just say return, bracket open, and you put what you want to return. So that's it for a function. And how do you use the function? To call the function, you just write the name of the function, and you would write the values for each argument. And you can assign this function to a variable, and it works. And you see the value, the result, what it returns. Now, you may have codes that just execute instructions but do not return anything. You can make a process out of them. So a process is just similar to a function. The syntax is the same way as a function. You have arguments, you can put different kinds of arguments, and you put your instructions inside. The only difference between the process and a function is a process doesn't have a return. So you don't return anything, you just execute the instructions inside, but you don't return. And the same way you can call this function exactly the process exactly the same way you call a function, just yeah, but you can't assign it to a variable because it doesn't have any value to be returned. Now, the last thing is a good way to avoid messy code is I can create functions for different codes that I want to use more than once in my script, and I can keep them in a script, in a different script. So this is an example. You have the doc script. I created 2 functions and I kept them here. So this is a script where I will only put functions there. Now, in my notebook, I can call this script inside, so source .r, and when I call this, I can call the functions that are in this script. So every function that is found in this script, I can use it inside this notebook just because I've called the script into the notebook. So that's a way to keep a very clean code, and to have very organized coding, so that when you come back 10 days later, you're like, okay, I know what I'm doing. I know what I did, and I'm not confused. Okay, we've come to the end of this workshop. Are there any questions? Is there something someone wants me to clarify?
So guys, if you have a question, you can unmute yourself and ask directly. So Yolande, I think it's all clear, hopefully.
Okay. Thank you very much. This is it's really an honor to present this and to work with you guys. And just to remember, if you don't know a function in R, you can always use the help, and you would find documentations about that function and examples on how to use them. Try to do the challenge I put out. Try to do them on your own, and if you find results and you want to see another way of doing it, you can check the solution HTML, and you'll find what I propose as solution. Reach out to us and tell us how you felt about the challenge. Was it so difficult or was it very easy? I would like to know. And thank you very much.
Thank you, Yolande. Thank you, Yolande, and thank you, guys. As Yolande mentioned, please send us your questions and feedback. I will send you later the recording for this workshop. And also, I would like to hear from you, maybe now or by email. What do you think the level for this workshop? Was it easy to follow or not? Did you get lost too much? And something like that. So thank you for today, and I hope you a good weekend if you have in your country weekend. So thank you, and
Thank you.
bye bye.
Bye.